Hey, boys and girls. It's just like class, right? Well, listen, this is my first video, except for the intro video that you got. So y'all be patient with me. Um, Hopefully this will go well. So the first thing I want to talk about is that we had covered the water cycle, and I will probably do some videos on the water cycle. I thought you guys did a really good job on that. It's unfortunate that this all happened because we were right on our way to going into weather. But the first thing we're going to do, since we're not in school now, is we're going to go and we're going to learn about heat transfers. Now, if you're at home and you're watching this video, this is basically what the note sheet would look like if I gave it to you. We only had 4 words for this one. These are the heat transfers, okay? The radiation, convection, and conduction. They're pretty easy to learn. There is one that is kind of a mind bender in a way, but we're going to get through that. But the first thing we want to talk about is heat transfer. Now, what is heat transfer? Well, if you just reverse those words, it is a transfer of heat. And what does transferring mean? Transferring means to move from one thing to another thing. So if you get into college or something and you don't like the school, well, you can transfer to another school and hopefully you'll find your way there. Heat transfers itself in 3 different ways, okay? And heat always travels from a high temperature object to a lower temperature object, okay? So the thing we want to write down for heat transfer is this, okay? And it's really, really simple. It's the transfer of heat from a warmer object, okay, to where? From a warmer object to a cooler object, okay? So this can go many, many different ways, all right? Well, I'm going to give you 2 examples and hopefully they'll really help you understand this. So if you're watching at home, we've talked about our internal body temperature quite a bit. We've talked about viruses and bacteria and what those things can make our body temperature do, which is go up. Obviously, if your body temperature gets too low, you can go into hypothermia and die. So all of us, which we've talked about, are roughly 98.7 degrees Fahrenheit. Now you could deviate from that 0.7 a little bit. You could go up to 98.9, 98.5, somewhere around in there. Some of you might be running about 99 degrees and it's totally normal. Some people run a little hotter than others. Some people run a little bit cooler than others, but this is the average, okay? Now, when I was a little kid, I was mesmerized by fire, and stoves and things like that, just like all of us were, we sit there and we see adults around something, and they're like, hey, don't get near here, and all you want to do is get closer, right? Well, obviously, we all learn our lesson. So let's take this for an example. So with us sitting at 98.7, which we're 98.7, we're babies too, and young kids that, we don't really know what's going on. We're still the same temperature. Let's say that it's Thanksgiving and your parents are cooking and the stove is set to 350 degrees Fahrenheit, which is about an average temperature to cook at for most people. Well, for most things in the oven. Some require a little bit more heat, some require a little less. So right here we have a good indication of 2 differing heats, okay? 98.7 is pretty hot. We'll go outside on a day that's 99 degrees and we're going to do some sweating, right? It's going to be hot. We're going to probably have to turn the air conditioner on. But it's nowhere comparable to 350 degrees. We could not live in that type of environment. It would burn us up. We would not be able to breathe in that environment. It would burn our lungs up. So in this situation, if we read our heat transfer definition, you have a scenario that has 2 different temperatures. Obviously, which one's the hottest? Well, the stove is obviously the hottest, okay? 350 degrees is 3.5 times almost more than 98.7. So even though you're still hot, you're gonna be the cool object. So if you take your hand and you run it over that stove, what's gonna happen? the heat from the stove is going to transfer to your hand and you will be burned. Okay? So that's one way that heat can transfer itself. So that's one example you could use. Now let's use your body heat again. And then we're going to talk about something a little different. So what did we say our body heat was? Most people's average is 98.7 degrees Fahrenheit. All right. Let's take something that's going to be cold. This is a good example too. Let's take a piece of ice. All right. So you're sitting here almost 98, 99 degrees. And then a piece of ice, let's say, is 32 degrees Fahrenheit, 0 degrees Celsius. Now, we have a temperature difference here. We have freezing, which is 30 degrees Fahrenheit, so that is going to be a freezing temperature. Okay, and here you are, your own little furnace at 98.7, roughly. Which one of these is the hotter object? Well, obviously, it's 98.7. So if you go, and you can do this at home, you go and you get you a piece of ice out of your freezer and just lay it on your hand. Well, then the heat from your body is going to go to that piece of ice and it is going to make it do what? Melt. Okay? That is a transference of heat. Okay, sometimes maybe you've held something in your hand, like a pencil or something, and you felt it with your other hand and it feels really warm. Well, you're transferring your heat to that. Okay? Now, this is a really good example to use, and so is the one about the oven. Those are really good things to put in the back of your mind to kind of understand this transference of heat, because that could be a question you could see on the EOG is how does heat move? Heat always is going to move from a hotter object to the colder object. That's why we can get burned so easily. You know, there's a lot of things out there that are very high in temperatures, such as fire. You know, those things, they will burn us up. You know, hot metal. Those are not good for us because the transfer of heat from that can cause us to get very, very burned and get hurt very badly. So just remember that, and we're going to go to radiation next, okay?